Assalamualaikum warahmatullahi wabarakatuh, and hello, welcome to electrical technology class. For this week, week 1, we will start with the chapter 1, which is DC circuit. And for week 1, we only focus on the basic electrical concept. What is electricity? Electricity is the flow or movement of electron through a material. And the current is the rate of flow of electron through a conductor. Usually the current is measured in ampere, amps or ampere. The unit is A. There are two types of current. Either it is a direct current or alternating current. So what is direct current? Direct current is basically the current move in only one direction. As you can see here, the current versus time graph, you can see that the current will never meet zero. Means that it is only move in one direction. So as long as it is not contact with zero magnitude, it is considered a DC current or direct current. How about alternating current? Alternating current is basically the current change one direction and then goes in one direction and then goes to the other direction. For AC current, as long as it is meet at zero, it is considered as AC current. As you can see here, the magnitude will goes to zero and goes to negative. It will become a AC current. Now you know the current. Now we move on to the circuit. There are two types of circuit. Either it is DC or AC circuit. Basically, if DC circuit means that the supply is DC current. The current flowing through it is DC current. And if it is a AC circuit, the current flowing through the circuit is AC current. So next we talk about charge, or we can also call it Q. It is the basic quantity in electrical circuit. There are two types of charge, either can be positive or negative. And the SI unit is coulomb. You need to know how much is 1 coulomb. How much electron is 1 coulomb. This is usually will be asked in the theoretical part, so you need to know also. The current. Last time I was only show you what is a simple brief explanation on the current. This one is the more details explanation of the current. Current is basically defined as the amount of electrical charge in coulomb flowing through the surface over time. Basically coulomb over second. So you can see the derivation here, the formula here, I equals to dq over dt. It is the rate of flowing. And the unit I mentioned before is ampere or A. And if you draw in the circuit, you have to show it as a arrow. The current always go through element. This is important. There are two types of current direction. So it can either conventional current direction or electron flow or electron current direction. So for this class we use a conventional current. If you use electron current direction, you have to use a different book or different slide. Everything will be changed. What is the difference between the conventional current and direct current? Conventional current and electron current. The conventional current move from positive to negative, and electron current move from negative to positive. So for this class, always use the flow of current from positive to negative. I repeat, positive to negative. So beside current, another important component in electrical is the voltage. Voltage is basically the force pushing the electron to a material. So basically the equation is just V equals to d work over dq. Okay, work need to be done to move an electron. Okay, not an electron, the charge. Move the charge. Okay, another important part in voltage, you need to know differentiate between VAB and VBA. As you can see here, okay, if it said that VAB is 9 volt, then VBA is negative 9 volt. Okay, now we put everything that we have learned into practice. Okay, as you can see here are a simple circuit which consists of a voltage source, which is basically a circle with plus and minus. Okay, and a resistor which is just a zigzag. Okay, and the voltage source is 9 volt. Okay, the unit for voltage is 9 volt. Okay, don't forget that. Now we look at this. Okay, remember that I said we focus on the conventional current, means that the current will move from positive to negative. Okay, how to represent that direction of current is we just put an arrow like this. Okay, always positive source to negative. Okay, then the abbreviation for current is I. Okay, and the unit is, for example, the current is 3 ampere. Okay, you have to differentiate. The current is represent as I, and the unit of the current is ampere. Okay, make sure you know how to differentiate this. Okay, the direction goes from positive to negative. Okay, now how about voltage? Okay, when current pass through a resistor, okay, make sure you label the current goes into positive and go out from the resistor is negative. Okay, this is a standard practice in electrical. So make sure if the current goes into the resistor, it will become positive, and goes out, it will become negative. So automatically, because this is just a simple circuit, and this one always be 9 volt. But what is the unit? Okay, can be positive and negative. Okay, this one is 9 volt. Okay, because it is the same. Okay, this, okay, if we have a and B, okay, VAB is equals to 9 volt. Okay, basically this one is positive, this one is negative. Okay, V positive, negative. Don't put the V positive, negative, but put VAB if there are point here. Okay, A and B. So VAB equals to 9 volt. So how about VBA? Means that this one to this one, it is against the current, so it's basically is negative 9 volt. So you have to make sure that you differentiate between VAB and VBA, and what is positive, what is negative for voltage. Okay, and the direction of current. So this is important when you use electrical theorem. Okay, if you make mistake for positive and negative, everything will be wrong from beginning, so you can lose a lot of mark if you don't know how to differentiate between positive and negative and the direction of current. Okay, previously we talked about electrical quantity, which is current and voltage. Now the third unit that is important when it's come to electrical is energy. Okay, what is energy? Energy is the ability or capacity to do work. Okay, electricity is one form of energy. Okay, the other form is chemical, lights, okay, heat. That one is another form of energy. And in electrical utilities company, okay, energy usually in measure in kilowatt hour. Okay, kilowatt hour. But usually we also can know that the energy is in joule. 1 kilowatt hour equals to 3600,000, okay, 3.6 megajoule. Okay. The fourth quantity that you need to know is electrical power. Okay. What is electrical power? Power is defined as the amount of work done by an electrical current or the rate at which electrical energy is transferred. Okay. It also refers to how rapid the energy is used and or converted. Okay. The SI unit for power is watt. And okay, how to calculate it is just P equals to VI. You just need to multiply the current with the voltage. You get the power. Okay. Previously, I showed that the formula for the power is P equals to VI. But sometimes the V or I is not present. So if V or I is not present but the resistance value is present, so you can use the resistance or the voltage or current. So as you can see here that the original equation is P equals to VI. Then using the Ohm's law, we modified the equation. P equals to V squared over R or P equals to I squared R. Okay, make sure that you know how to differentiate it. Okay, if the circuit has voltage and R only, so don't forget the V squared divided by R. So voltage divide and the current is multiply. Okay. Power can be supplied or absorbed. So you need to know that if the power is absorbed, the sign of the power is positive. But if the power is supplied, okay, the sign of the power is negative. Okay, as I mentioned, okay, power positive is absorbed, power negative is supply. Okay, as you can see here, okay, P equals to VI. Okay, so current is 3. Okay, this is 9 volt. So 9 multiplied by 3 so 27 watt. Okay, so but for this part, okay, so the current goes out from positive, so you cannot use, okay, you have to put P, okay, equals to negative VI because the current goes out from positive. This one goes into, so you just put here. Okay, so P equals to negative 9 multiplied by 3, 27 watt. Okay, so you need to differentiate between the, okay, positive goes into the load and negative goes out the source. Okay, so don't forget the negative. So let's take a look at example. Okay, what is the power output of an electrical kettle connected to the 230 volt when a current is 10 ampere? So find P when the V and I is given. So P equals to VI. So the answer is just multiply 230 volt multiplied by 10 ampere. You get 2300 watt power. Okay, here are another example. Okay, the question asks how to calculate R and V if the power has been absorbed by the R is 1.6 milliwatt. So the current is 0.4 milliampere. So if you look at the original formula, P equals to I squared R. Okay, so you have to rearrange it again. Okay, because you only have the information is power and ampere, right? So you have to use the formula P equals to I squared R because you want to find R. R equals to P divided by I squared. Okay, you just insert the value, okay, 1.6 milliwatt and 0.4 milliampere into the equation. For Vs, you use P equals to Vi. So you automatically get the V equals to P divided by I, and just insert the value, you get the voltage. Okay. Okay. Make sure that you know the unit. Okay. Make sure you know the quantity, symbol, unit, and formula. So for charge is coulomb. The charge is Q, and the unit is coulomb. So current, the symbol is I, the unit is ampere. Voltage V, okay. The unit also volt, okay. The energy is watt, or the unit is, and the energy symbol is W, the unit is joule. For power, okay, the symbol is P, the unit is watt. So energy and power, you have to differentiate. You have to be careful because energy symbol is W, power unit is W also. So next is the resistance. Okay, you can see use the symbol R for resistance, and the unit is ohm. Okay, omega. Okay, capacitor, you need to know that the symbol is C and the unit is farad. Okay, inductor. Okay, the symbol is L and the unit is Henry or hash. Frequency, this is the standard F, Hz. Okay, the unit is Hz. And the impedance, okay, this one for AC circuit, for the impedance, the symbol is Z. The unit is also ohm. Same as reactance, this one for AC circuit, impedance and reactance is AC circuit. Okay, and the symbol is X. The unit is ohm also. So you have to memorize all of this. Okay, this one will be come out in the theory part of the test and exam. Okay, you also need to know what is electrical circuit and electrical network. So you just remember the definition. Next, we learn about the circuit element. There are two types of circuit element, which is active and passive. So what is the difference is active element is provide energy. Okay, passive element absorb energy. So remember I said that P positive, okay, and P negative. Okay, so positive power is the passive element. Okay, negative power is the active element. So you need to know what is the definition of the active element and passive element, and then you need to know what is the function, what is the example. So for active element, there are voltage source, current source, generator or battery. For passive element, it can be resistor, inductor or capacitor. So you just memorize this. So we move on to the active element. So as I mentioned before, the common one is the voltage source. You need to know both of these symbols. Okay, either you can use the round one or the dash one. So make sure that the longer line is the positive part and the shorter line is the negative part. Beside voltage source, there is also a current source. So the symbol is round and at the center there is a arrow. So you need to know the voltage source and the current source. Okay, I think all students know what is Ohm's law. Basically, voltage is directly proportional to current. So you need to remember what is the formula. V equals to Ri. That's it. This is the Ohm's law. Try to memorize the definition because it's usually come out in the theory. But no need to memorize word by word. Just understand a little bit. Here are one example problem. Okay, a 9-volt battery supply power to a cordless curling iron with a resistance of 18 ohm. How much is the current flowing through the curling iron? So using Ohm's law, so I equals to V divided by R. So 9 volt divided by 18. So the current will be 0.5 ampere. Okay, next is the network topology. Okay, this one is important because it will be used in the next part, which is mesh or nodal analysis. So if, for example, you have a circuit like this, okay, if you redraw this again, you can get like this. Okay, this one is considered the same circuit. Okay, you need to know how to redraw everything again. If they given at the right side circuit, okay, you need to know how to convert back to the left side. Okay. Okay, you also need to know how to differentiate between node, branch, mesh, and loop. Okay, node is basically a joint point between two or more circuit element. Okay, means that the node is basically is between the element. Element can be, like I said before, active and passive element. Can be a voltage source, resistance. Okay, anything that connect from elements to elements is called nodes. Okay, branch is basically just element. Okay, it's the same thing. Okay, mesh is a closed loop path in an electrical circuit. Okay, loop is also a path whose last node is the same as the starting node. Okay, I will give the example next. Okay, here how to differentiate between different node, branch, and mesh. Okay, we start with branch. Okay, branch, as I said before, branch is actually just a element. So this one is branch, one branch. This is one branch. This is one branch. This is one branch. So 1, 2, 3, and this one is 4. So there are 4 branches. Okay. Any component that exists is called branches. How about node? So what is node? So I let in the definition, node is basically just a point of connection between two branch. So if you can see here, this is a branch. This is a branch. This is node. This is node. Okay, and this is node. So basically there are 3 nodes available here. Okay, 1, 2, 3. This one is considered only one node because there is no other component. Okay, this one is also considered one node because there is no other component. So there are 1, 2, 3. 3 nodes available. Okay, now we look at on loop or mesh. Okay, loop or mesh is basically the same thing. Okay, loop or mesh is basically one complete circle. Okay, as you can see here, this is one. Okay, one loop or mesh, 2 loop. Okay, this is 1 and 2. This is called a independent loop or independent mesh. There is also a dependent loop where it can combine together. Okay, if the question asks how many loop in this circuit, it is 3. Okay, 1, 2, and 3. But how many independent loop is actually only 2. Okay, this one and this one. Okay, I give you another example. Okay, start with branch. Okay, this is one branch, one branch, one branch, one branch, one branch, one branch, and one branch. So 1, 2, 3, 4, 5, 6, 7. There are 7 branches. Okay, so any element that available is called branches. Now how about node? Okay, you can see that this is one node. Okay, this is one node, this is one node, this is one node, this is one node. This one is considered here node because there is no other element. Okay, this one also considered as one node. Okay, so 1, 2, 3, 4, 5. There are 5 nodes. Okay, how about loop? Okay, loop can be very tricky if the loop is 3. Okay, more than 3. Okay, first one. Okay, how about this? Okay, this one is first loop. Okay, loop 1, loop 2, and loop 3. There are 3 independent loop. But how about loop or dependent loop? So you can see that, okay, 1, 2, 3, then 4, then this one is, then this one is 5. Okay, and there will be 5 loop, right? This one and this one cannot be combined. Okay, there are 5 dependent loop. Okay, we have finished the first part of the class for chapter 1, which, so we can conclude that there are various definition and theory you need to memorize. Okay, then you are introduced with the current, the voltage, how the direction of the current is defined, how is the voltage is defined, how is the energy is calculated, how the power is calculated. Okay, there are 3 equations for power. Then there also you need to memorize the parameter, the symbols, and the unit. That's include the reactance, impedance, and the table. Okay, then you need to know the elements, which are active element or passive element. Then we also discuss about the Ohm's law, which is V equals to IR. And lastly, we also discuss about the branch, node, and mesh or loop. Okay, for the first part, you need to understand and memorize all these mentioned parameter. Okay, thank you.